So this week is all about univariate data, descriptive statistics, and this is given in your D2L folder. It says univariate data examples, and what we will be discussing is how your assignment 2 is also oriented using this. So if you look at it, is the first example is, suppose you have been assigned by your university to conduct a study to recruit doctoral candidates. You are the one who's responsible for getting all the information and putting it in SPSS to analyze the characteristics, selection criteria, and other things. So here are some of the variables that you are gathering. You have an identification parameter, which is basically just identifying them. You have gender, SES, which is socio-economic status, ethnicity. You collect their GRE scores for the quantitative scores, and then the GRE for the verbal. You collect a subject pretest, and then the rating from 2 faculty interviews. So one of the first things that we have to do is we have to assign coding. We have to figure out how to code this data. So here is your coding of the doctoral applicant. Sorry about that sound. So here's my ID. Basically, it is just an ID number, so I don't have any coding for it. It will just tell me how many candidates I have. The gender is coded as 1 is male and 2 is female. Now remember the types of data and the scales of measurement. This is where it is very important, because what type of data is my gender? The gender is my nominal data, and it is actually dichotomous because it can only have 2 values, 1 or 2. So it is a dichotomous nominal data. You will ask yourself as to why we need to know about the type of data. It is because that determines, as you proceed, is what type of central tendency will give you the information, or looking at the dispersion is what makes sense. So let's look at SES, which is, this is my code for socioeconomic status of the applicant. I have given 3 nominal data. Once again, I have assigned a numerical value to low socioeconomic status, low SES, middle SES, and upper SES. So there are 3 different values assigned to this SES status. Ethnicity, again, this is my code for ethnicity is ethnic. And then I have 4 different values assigned. So I have white, African American, Asian, and 4th is Hispanic. Now, if you are conducting the research, you could also put a 5th category which says others, or you could have a combination. But here, for the purpose of this univariate data, I have only collected white, African American, Asian. So 1, 2, 3, 4. That is again your nominal category, nominal data set. Univariate, as you all know by now, I will repeat again, is deals with one set of data, and that is what we are doing, is one set of data. So GREQ, that is the GRE quantitative section, has a ratio scale which is 200 to 800, so they can have any value between them. GRE verbal is again a ratio scale from 200 to 800, any value can be taken. The pretest is the subject area pretest, which can have any value from 0 to 100. So here I had these 3 as nominal data, these 3 as my ratio or scale data, and now I have rating 1 and rating 2. What do you think the rating 1 and rating 2 would be? I'll give a pause for you guys to think about it. Your rating 1 and rating 2 are ordinal data set because you are ranking them. Remember the order that we have. So 1 to 10 is a rating. So 1 rating shows it is least and a 10 rating shows it is the best. And so there is order given. So this is ranking of the participants. So rating 1 and rating 2 are ordinal data set. So here I have is the whole data set. I have 20 participants. I have gender, coded gender, SES, ethnic, GREQ, GREV, the pretest, the rating from one faculty member, and the rating from the second faculty member. So if I look at this, then let's look at the questions here. So I'm going to change my window view so that we can have both of these things side by side. So here is my data set. So this is how your assignment 2 is. So you have first thing to look for, are there any missing data? So do you see if there is any missing data? No. Do you see if there are any outliers? When we talk about outliers is when we are talking about, suppose you know that the maximum for the GREQ is around 675 and the maximum becomes like 1200. So that's like an outlier, or a minimum becomes like 20 or 30, which is really bad. So this is what is called an outlier. How many students in the sample are female? So this is very easy to see. We go back to gender. We know 1 was a male and 2 was a female. So to find out how many students in the sample are female, we simply count the number of 2s. So like 1, 2, 3, 4. How many number of 2s they are? I am not going to do this because this is what your assignment is about. How many students come from low SCS backgrounds? So once again, what is my coding for lower SCS? It is 1. So I go back and I start counting. 1, 2, 3, 4, 5. And if I have missed any, make sure that you double check that. What percentage of sample is African American? So remember, here it is asking you the percentage of African American. So the best way to do that is, once again, I go back to my code. I found out which is the code for African American. How do we find out the percentage? You find out how many 2s you have, because that is African American. So how many African Americans do you have? And then you are going to divide it by the total data set. And the total data set is 20 participants. And remember, it's a percentage. So what is the number that we multiply it by? It is 100. So we have African Americans divided by my total data set times 100. This is how we do percentage. So here again, it is talking about percentage of applicants received a rating of 8 and lower. So I have to go back and look at the percentage of participants who have received a rating of 8 and lower. So basically 7 is included, but 9 or 8 is not included. 8 is included, but 9 or 10 is not included. So there are two ways of doing this. You can find the ratings 1 to 8, or you can find the ratings for 9 and 10 and then subtract it. Now, one thing to remember about this is the rating. We have 2 sets of rating. So you actually will have a rating here and you will have a rating here. So the total number of applicants or total number of ratings that becomes here is 40. So we look at 9 and 10. We find out how many they are. We subtract it from 40, which is my numerator, and then divide it by 40 and take the percentage of it. Or you can do it in the other way, in which you find out from 1 to 8 how many have got a rating 1 to 8. So you go for rating 1, you go for rating 2, you find out how many they are, and then divide it by 40. And then you have multiply by, come on, you know, you got it, multiply by 100. So next question is, how many students are Asian? Once again, I go back to my coding. Asian is number 3. This is just asking you how many students, not asking you a percentage. So I go back and look at ethnicity, and then I look at What was my coding? It was 3. Do I have any 3s or not? So Asians. And here, as you must have already guessed, I cannot see any 3. So that means, what would you have? That means 0 participants, basically. I'm like giving away the answers here. Come on, right? All right. If there were a minimum cutoff for the GREQ, so I'm looking at the quantitative part of 480, what percentage of applicants would be accepted? So the minimum is 480. That means anything above 480 and above is accepted. So then you go down the list. So 445 is not accepted, but 490 is accepted. 589 are accepted. The same thing. You calculate how many have 480 and above. Then what are you going to divide it by? What is the total number of participants? We are only looking, or applicants, we are only looking at this one. So that is 20. And to find the percentage, you multiply it by, I'm going to leave it blank. You're going to multiply it by, so the multiply it by 100. Yes, you guys have got it. Very good. Very nice. So now let's go to the next question. Now we have a question. If your supervisor asked you to provide measures of central tendency for the variable SCS, and then here is, what would you recommend? So remember our chapter that was there when we talked about the measures of central tendency. I'm going to open up that page and bring it in the view. Mean, median, mode. So this was our measures of central tendency, mean, median, mode. So you know how to calculate those. So, but you have to think about what makes sense. For example, let's do the first one, SES. SES has 1 for lower, 2 for middle, and 3 for upper. If I take a mean of SES and it comes out to be 2.2, does that make any sense to you? So there is no meaning to it, right? So here I may want to know the mode of it. That means how many are the most of the participants, lower, middle, or upper, because this is a nominal data set. So I want to know either the mode of it. I may even want to know the middle of it, but the mode seems to be a much better category. So here what you are going to put is, I will put mode and I will say because it is a nominal data set. So you're going to do the same for GREQ, GRE verbal, rating 1 and rating 2. Remember that GREQ is your ratio scale level, GRE verbal is your ratio, rating 1 and 2 are your ordinal scales. So let's move on to the next question. Now, if your supervisor wants to know the frequency distribution of the students who reported minority status, what would you say? So this is done using SPSS. I already inputted the data set in SPSS, and I'm going to move my window to show you guys what it looks like. So this is what the SPSS data set looks like. If I show the variable view, I already have gender. I have given the variable which is nominal, nominal, nominal. And see here, I need to change this to an ordinal scale because they are ordinal scales. And then I said no decimal points. And so this is my variable. So how do I do a frequency table? So to do a frequency table, you go to Analyze, Descriptive, and Frequencies. You don't have to do this, but it is always good to know what you are doing. So I'm going to select all of my variables because I want to do it on all the variables. I am going to press OK. I can even do charts and statistics. So I'm just going to play because I want to just find out the frequency. This is where it opens up. My frequency distribution opens up. So these are the frequency tables, and if you look at the overall statistics, you have gender, SES, so we have 20 data points. This is what is given. But if you look at the gender one, You can see 1 and 2. Remember our coding. 1 was for males and 2 was for females. So it tells you how many frequency were there. It also gives you a percentage of it. And obviously when you have to find the percentage of the total, it would be 100% for 20 of them. Here is your SCS, the same way. This is a frequency table. The ethnicity, it provides you the frequency for 1, 2, and 4. So you don't have any 3 here. Remember, go back to the data and see how many Asians do we have. The next one is the GREQ, which is the GRE quantitative. So if you will look at this, they all had different scores. So there is a frequency of 1. So frequency table for GREQ doesn't really make much sense. And so I wanted to show you, this data is not really needed for us. And when you look at the GRE verbal, you can see that there were some students that got, some candidates that got 2, like they got the same score, but it still doesn't make much sense to have this kind of an individual score frequency data. This is again pre-test. Now the ratings make sense because it is telling us that if you look at rating 1, it was 5 and above, how many got a 6, how many got a 7, how many got an 8, and the percentage. So rating makes a sense for us. It is an ordinal data set. So knowing each one, now calculating the mean of these don't make sense. So what do you think would be the best thing to know about this? These are all tables in SPSS, and I actually put all these tables. These all tables are in your Univariate data example. I'm going to move this here. Okay, give me a second. So as you can see, these are all the tables of the pre-test, rating 1, rating 2. Then you previously have your GRE verbal, quantitative, and here. So all the outputs data set is in your thing. I also, so now let's look at some descriptive statistics in SPSS. Okay, so I'm going to look at descriptive statistics. So I am going to open this up again, my SPSS, and I'm going to go to analyze descriptive statistics. So I want descriptives now. So I want descriptives on all of them. I select them, move them. I'm going to go to options. So what all do I need? I need my standard deviation. I need a minimum and a maximum. I would like to calculate the range. I would like to have some variance. Do you want some kurtosis and skewness? Why not? Let's see what comes out to be. And then I press continue. So if I go down, here is my descriptive statistics. Here is the descriptive statistics for the whole of the data. So gender, how many there were, obviously our data set N was 20, range was, now gender range doesn't make a sense because it is a nominal data. 1 is male, 2 is female, like minimum and maximum don't make sense in gender, SCS, and ethnicity because it is nominal data, like it is nominal data set. There is no sense in doing like 1 minus 2, males minus females. It is sense in making how many males and how many females, but 1 minus 2 would just give you a 1. So range of 1 doesn't make sense. Range of 2 and range of 3 doesn't make sense. What makes sense is the GREQ, because it gives you what is the minimum, what is the maximum. So what was the range over here? Again, minimum, maximum. Here are my means. Once again, 1.45 in gender mean. Does it make sense? It doesn't really make sense. So you have to be careful. We ran for all of it, but what makes sense to you? So mean for this one, GREQ, GRE verbal, that makes sense. Then you have a pre-test, rating. You get the standard deviation right over here. That standard deviation means how much is one deviation from the mean. So you have 146 plus minus 123.2. That is your standard deviation. And that is how that data set descriptive statistics would be written. Variance is just the square of standard deviation. Your skewness, you can see, is positive 0.08, but for verbal, it is 0.375, which is higher. So that is something. And you have your kurtosis here. It tells you that the skewness is a negative skewness. Remember how we talked about positive skewness and negative skewness. Where does the tail go for a positive skewed data set and for a negative skewed data set? So those are the informations that you are getting. We have questions related to the analysis, which we will talk about it. But this table is in the univariate data example. So here is the table and here are the questions. I'm going to make the view to be smaller so that we can see both of them together. So here are my questions. So here is the data set. This is the descriptive data set and here are my questions. So if I look at my questions, is the pool of our applicants more varied in terms of verbal or quantitative ability? So look at this. So I am looking at variability. Is what does variability stands for? That is the standard deviation. So which one is more variable? Which one scores are more spread out is what it is. So you're looking at standard deviation and then talking about it. So when you're talking about support this response with appropriate sample statistics, you need to talk about the variability. What is the way you can talk about standard deviation or variance, and then you can talk about how the variance of verbal or quantitative is this compared to verbal. I'm like giving out the answers here. Which variable appears to be most skewed? What is that one? We were just talking about it. Report that value that describes the skewness and what it means. Remember, positive skewness, negative skewness. Positive skewness, where does the tail lie? To the left or to the right? Those are the things that you talk about. Create a set of criteria to select the top 3 students in our program. This is like a really good question. If I want to select top 3 students, what would be my criteria for it? I want to see what you guys come up with the answer to this question, and I may give bonus points, for this question because I think this is a really good one because you are going to support your decision using the information. Okay, I kind of give you a hint when I say 4 variables so that you can think about what I'm talking here is which variable. So think about the criteria that you are going to set up to select the top 3 students in the program for the program. And obviously, bonus question, right? Then you have your graphs for the criteria selection over here. I've made some graphs over here. So these are the bar graphs. We don't have histograms, once again, for gender, SES, ethnicity, because they are normal data set. Gender is actually a dichotomous, so we are not going to create histograms for it. We are going to create bar graph diagrams. But we are going to have histograms for the GRE quantitative and then GRE verbal and other pretest. Rating 1, rating 2, we've created histograms to it. You don't really need histograms for it, but I just did the histogram just to show you guys a spread kind of a way, because it's an ordinal data set. But the histograms are mainly for the GRE verbal, pretest, and GRE quantitative. All right, so we are going to go look at our second example now. So I paused the video to adjust the window so that there wasn't any gap. So here is my, let's go down to my second example. So this is my second example. And I can adjust this window more. So when looking at the second example, you can see that we have three variables here. So we have the age, that is the actual age of the student when he or she is enrolled in beginning statistics course. And then we have the number of credits completed at a university by the student beyond his or her most recent degree. And then the last one we have is the TEA experience. So basically the TEA experience is a dichotomous nominal data set. That means, do you have any experience? 0 means no, 1 means yes. So if this is my descriptive statistics, the university, first of all, I am looking at what is my N. I am given N here, valid N, list-wise. So what does list-wise mean? You have to figure that out. Is list-wise deletion of missing data. So there is list-wise and pair-wise. Now you must have already read about list-wise or heard about list-wise while you were dealing with, or you were in the intro to research class. Basically, list-wise is when you delete. If there is one thing missing, you delete the entire entry. And then pairwise is you do not do that way. So there is listwise and pairwise deletion are the most common techniques of handling missing data in a set. People generally do listwise, but pairwise is also common because you try to minimize the loss of data. So here you can see it is now 199 with list-wise deletion, and you have the credits you had 201, and then for TA experience I had 209, and age I had 207. So this is giving me the number of data points that I have. What is the mean number of hours taken? So here again, you're looking at mean number of hours. Where would you go? So I am looking at U credit. That means I'm looking at number of credits, number of hours taken, which is the number of credits. So I'm looking at this, and then I go to my mean and find the answer. How many hours represent one standard deviation above and below the mean? Don't forget, above the mean plus 1 standard deviation, below the mean minus 1 standard deviation. But here you're not giving the standard deviation. You're finding out how many hours represented. So I'm going to let you do this. This is exactly what we've been talking about in the example 1 also. What is the mean age of our sample? You know how to look at the mean age of the sample. What is the mean age that is there? Then you go down and we look at what is the age represents the middle 95th percentile of the sample. Remember how we found out the 95th percentile. What is 95th percentile on a normal distribution curve? Let me open that one up once again for you guys. So here is that normal distribution curve. So where would the 95th percentile lie? 1 standard deviation below and above the mean is how much? 68 percentile, because you're adding 34.13 plus 34.13. So how much would be 95th percentile? What do you think that would be? How much percentage would you need to add? This is a easy answer. Please think about it. How much, if 1 is 968, we've talked about how many scores lie in the 95th percentile. How many deviations below the mean and how many deviations above the mean? How old is the oldest person? How young is the youngest person? Age group. So if you look at this, you have your minimum, maximum. What is the range? Range is maximum minus the minimum, what is the minimum number of hours taken. So all this descriptive statistics, you can find it from this table. If you look over here, I have put in the PDFs. So to get direct link to the PDF, you would have to download this document and then get the PDF and click on it and it will work. So if I click on it, it actually links to that one and it opens this one up, but it will not work if you do not download it. But it is also uploaded as separate files also, so you don't have to worry about it. The skewness for the age is the skewness for however is larger than, and so all of these are fill in the blanks for you, which should be easy for you to find out. Is the value was this for age and this for Euclid. So all of this is given through this table. So now in the end, you have is in regards to skewness. What does a larger number? Can it be positive or negative? Does it matter that T experience is skewed? What do you think? This is a good question. And why not? Okay, and then kurtosis, what does a positive number indicate? What does a negative number indicate? This is what your assignment 2 is about. If you have any question, please do not hesitate to post on the course question discussion board. The grading is given on the top of it. Did I give the grading on the top? I'm going to add the grading scale for it, like how many points is each question, so that you guys have that while you're attempting it also. Okay, any questions, please don't hesitate to put on the course question discussion board. I look forward to seeing your understanding of descriptive statistics. Have a great day.